Okay, this question appeared on a 2020 AMC 12 exam. Let me just talk about that a bit. And the AMC 12, get my highlighter out. There's 25 questions on it. They're multiple choice, and you're given 75 minutes to complete the exam. They're given to high school students. And what they're trying to do is identify, and by the way, a large number of high school students take it. They're trying to identify students that are capable of studying mathematics at a higher level. And that's the reason they give the exams. Of course, it's a large number of students taking it, and then a large number of students do well on it. And of course, from that large number, it gets winnowed down eventually to a team of really good students, all right? But the bottom line is I felt this was a good problem. I felt it pertained to what we were learning in Math 120. So it says over here, let AN, this is a sequence of numbers, and that's a sequence of numbers, and they tell me that they're real numbers, right? So they're a sequence of real numbers. And they go on to tell me that this over here is held to be true, and that's nice to know, by the way, if that's held to be true. One thing's nice to also understand is that they're using the letter I, and I, they're telling you, is the square root of -1. And then they ask about this over here. They say, I wonder what the sum is, and they have choices over here, and the choices all look very, very simple. Like it's 3/8, 7/16, 1/2, 9/16, 4/7. You could imagine some students at this point would be lost, and they would make a guess at it, all right? So I'm not that, really the point of this is not to make a guess at it. The point of this is to understand what they're asking you to do. So the first thing I did, I want to point out to you, I kind of looked at the sum, and I realized they want a closed form of the sum, which means they want some answer at the end of it, and it's an infinite number of terms, right? So what I started to do, I started to write it down. So I looked at this, and I started to write down what it would look like. It looks like this over here. Now, one thing that immediately comes to mind is it sure does, at least the bottom sure does look geometric, right? And what's unfortunate, though, is I'm seeing something in this thing I'm hoping to be geometric that creates a problem for me. And the problem is I don't see that in what they've given me. So what I would do is I would square that, both sides. So if this is true, whatever numbers they are, if I square both sides, that would remain to be true, all right? Let me put out what I mean by that. If you took the left side, which is 2 plus I, to the nth power, and you were to square that, it's the same thing as saying, AN plus BN I, that whole thing being squared. All right, so let me talk about, this is a milestone in the problem. Unfortunately, on these exams, they're not giving any credit for reaching a milestone. They're only going to give credit if you select the right answer. But remember, students are given a limited amount of time to do a problem like this. You could imagine how much pressure this is on a student to actually finish a problem, even if they knew what they were doing, how much pressure it is. But I would write this down now. Let me write down the right-hand side, pretty easy. AN squared. You would get minus BN squared, and you would get plus 2AN BNI. So right now I know I got something I need, but I do have some things I don't need. Like I don't need AN squared minus BN squared, but I do have something I need. Now looking at the left-hand side, what I'm going to do is, looking at the exponents, I'm just going to commute them around. And what you'd see over here is you'd see 2 plus I squared to the nth power. So I'm going to expand that, and if you did that, you would get 4, right, because 2 squared is 4. I squared would be -1, and then you would get plus 4I. Very simple expansion, by the way. And what do you give there? AN squared minus BN squared plus 2AN BNI. All right? So really what are you getting? You get 3 plus 4I to the nth power is the same thing as AN squared minus BN squared plus 2AN BN, and that's an I. All right? So again, I want to focus on what I need. I need this. And really what I'm looking at is there's a real part to the number. Let me outline what the real part is. This is the real part. This is what refers to as a real part. And this is the imaginary part of the number, the imaginary part. All right? So what I'm going to do is equate coefficients now. So let me get my eraser out. Now, I'm pretty satisfied to get there. And I want to start to erase things, and I'm satisfied with what I did over here. Let me just erase all this business over here. I think I'm making some headway on it. And what I'm going to claim over here is that this, making headway or not, I'm still not be able to do it. So I would say this over here. I'd say the imaginary part of the left-hand side, whatever that is, by the way, the imaginary part of the left-hand side, which is 3 plus 4i to the nth power, should be identical to the imaginary part of the right-hand side. And that coefficient is 2an bn, all right? So I'm going to claim that the left side's still difficult for me, but what I'm going to do is I wanted to get, let me get my eraser out again and outline what I want to get. I want to get something that looks like this over here, and I'm almost there. And being almost there, what I'm going to do is I'm going to divide both sides by 2 and 7 to the n. I can divide this by 2 and 7 to the n. All right? So what do I get? On the right-hand side, I would get an bn over 7 to the nth power. And that's exactly what I wanted, by the way. On the right-hand side, I'm still getting this, it's a problem for me. I'm getting 1/2. The imaginary part, I pulled the half out for a reason, by the way. And then it's going to be, well, they're both to the power n, so I can just simply do 3 plus 4i to the n. I'm sorry, not n. What am I saying? Get my eraser out. That's 7 to the n. All right? And then what I would do there is, I'm seeing, the right and left-hand sides are identical. And what I do now is do the sum of it, right? The sum of this. And I'll write that down for you. And so the sum of the left-hand side would be 1/2 times the sum. Well, I think I want to start at 0, right? 0 to infinity. And this would be 3 plus, whoops, forgot to put the imaginary thing there too, right? Put that down, imaginary. And I get 3 plus 4i over 7 to n would be the sum, n equals 0 to infinity, an bn over 7 to the nth power. And that's what I want. Now the question comes is, can I do that? All right, and it looks like you might be able to do it. Now certainly someone says, well, let me use Toma's theorem to figure that out, the nth power of it. You could, but I'm starting to hope that it's geometric. I'm hoping it's geometric. Now what do I mean by geometric? I'm hoping I'm getting something like this over here. I'll just write this down for you. And I'm going to say some r here, and I'll put r to the n. And what would this equal to? R to the 0 plus r to the 1 plus r to the 2. And this goes on forever. And this, hopefully some knowledge of that. Certainly if you can't remember that, you could easily derive it. It will be 1 over 1 minus r. All right? So I'm hoping it's geometric. This is only going to work, though, if r, the absolute value of the r, is a proper fraction less than, the absolute value is less than 1, all right? So between -1 and 1, not including those numbers. So that's what I'm hoping for, right? And that's written over here. I got this written over here, and this is going to hold. So what I do is I kind of write it down. I say, time to think about what that looks like. And so I took this thing here, which is what we have over here, and I start to write it down. I'm wondering, what does that look like? And I'm seeing it. I'm seeing this over here. All right, and I see a pattern to it. And before I do anything, I want to talk about the imaginary part of what looks like a common ratio for me. All right, so it's really that 3 plus 4i over 7, and I want the imaginary part of that. All right, and someone says, I wonder what that is. Well, if you looked at it, what's that going to be? It's going to be, let's see, 3 7s. Whoops, I forgot to put the imaginary part down. Let's go straight for it, all right? Well, you get 3 7s plus 4 7s. Well, you get 4 7s. That's what the imaginary, the coefficient of the I is going to be. And that's certainly less than 1, all right? So then, looking at it, and some of these common ratios, I'm seeing popping up over again, but I do want the, each time I want to take the imaginary part of it, and that's the coefficient on the I each time. So what I did was I kind of said, well, I just want the imaginary part of that. And I'm going to say, well, I know what the R is. The R is, basically this thing over here. This is the R. So what I do is I write that formula down. And what's that formula going to be? Well, let me just emphasize it's 1 over 1 minus that R. And this is the R each time. All right? 1, 2, 3, blah, blah, blah. That looks tough. So what I need to do is I need to simplify that because I need the imaginary part of it. So I'm going to go through that with you. I'll do it on the side for you. So I get, 1, and this would be 1 minus 3 plus 4i over 7. I'd multiply the top by 7 and the bottom by 7. You would get 7 on top. And on bottom you would get 7 minus 3 plus 4i. And that's going to be 7. And that would be 4 plus 4i. And I could factor a constant out from that, and that'll be 1/4. And what do you get? You get 1 over 1 plus I. All right? I'm sorry, there's still a 7 there. Sorry about that. All right? So let me tell you where that is. I'm sorry, I said, I made a mistake somewhere. I'm going to have to correct that. I just noticed it. I'm going to back up. I'm glad I made a mistake, by the way. And it's a common mistake, a mistake my students make all the time. Let's go through that again. Top is 7. The bottom is 7 minus, it's actually minus 3 plus 4i, which is minus 3 minus 4i. All right? And what do you get on top? You get 7, and you get 4 minus 4i in bottom. That was my mistake before. I just caught it. So it's 1/4 times 7 over 1 minus I. You know what I could do? I could pull a 7 over 2, couldn't I? Let me do that. I'll get this 7 here. I'll put it here. And I got this over here. All right? So I'm going to write the sum down now. Not the sum, this over here. I'm writing this over here. And I'll put it next to it. What do I got? I actually got 7/8 because it's 1/2 times that. So I get 7/8 times 1 over 1 minus I. And remember, I still need the imaginary part of this. And I'm not there yet. All right, the way I'm going to do that is I'm going to rationalize the bottom by multiplying by its conjugate, 1 plus I. And this would be 1 plus I. Let's do that. I'm still looking for that imaginary part, by the way. I'm going to pull a 7/8 out. And then you get, let's see, 1 plus I. And on bottom, you'd get 1 minus I squared, which is 2. All right? And what do you get there? Well, it looks like you get 7/16. And the imaginary part now of 1 plus I, which is just 1. So I get 7/16. All right? And again, long road, we got there. Got to the 7/16. Let's go back after all that work. Look back over here, and I'm seeing it right over here. All right? Now, by the way, sometimes I wonder, did I get tricked into doing something that I didn't understand? And that happens a lot, by the way. I get tricked. For example, a lot of these numbers over here, I didn't write the exam, by the way, but a lot of these numbers over here would be, if students had misunderstandings about certain concepts, by the way, they'd probably arrive at some of these numbers over here, if they had misunderstandings, by the way. So I'm going to say, I wonder, maybe I have a misunderstanding, and maybe it's really not 7/16. Maybe I really misunderstood the problem, and it's not 7/16. I misunderstood it. So what I'd like to do is I'd like to ask a machine to do the computation. And what I did was I asked Sage to do it, and I wrote this in, which is the complex number, right? And then what I did was I asked to do the sum from 0 to infinity. And this IMAG is taking the imaginary part. And I just wrote the sum down. And what does it give me? It gave me 7/16. So I'm going to say I didn't have any errors in thinking. Thank you. Oh, before I go, I want to point out, I do recommend in the notes I put something in magenta. If you click on that, you're going to see the instructor, another instructor go through that. And it certainly can't hurt to hear other people speak through the problem too. All right, and certainly try to convince yourself that you're capable of doing this with the information you have, although I think this problem is a difficult problem. Thank you.